anyway, so all I'm going to do is use the formula they gave me. So I write on my paper. It is important that I write g of -1 because they're asking me to find 3 different values. If I don't tell the grader which value I'm finding, he can't give me points. Like if there are simply 3 answers written on the paper, he has no idea which answer is which. So g of -1 is going to equal the integral -4 to -1 of f question. And the point is, don't stress about it. Just follow the rules you know. No big deal. So here's kind of, I have an integral here. It's the integral of this. I'm supposed to start at x equal -4. So come over here. So there we go, x equal -4.
Because the graph of f in terms of t, are t and x the same thing?
So yes, I think we talked about this a few days ago, but we haven't talked a lot, so it's a good question. This variable represents every value of x from -4 to wherever. So in this situation, this is representing the fact that we're going to plug into this all x values between -4 and -1. The only reason that this isn't an x is because these 2x values have a different meaning. Like I've often put a z here. They chose t. It means the same thing.
Okay.
This really is a function of x.
Okay.
So f is really f of x.
We just change it because it's 2 different variables.
Right, so they can't, these 2 variables cannot match because this is going to represent one specific x value that we choose. This will represent all the x values between here and here as the integral is computed. Does that answer your question? Good point. Anything else? So I start here at x equal -4. I'm supposed to integrate until x equal 1. Sorry, -1. Question?
So it's going to be f of -1 minus f of -4.
No, but 2 points for a good comment. If we could find capital F, yes. Capital F would be the antiderivative of small f. That's what you've been practicing on all of the 4 previous packets this unit.
Okay, yeah.
But we would have to find capital F, the antiderivative. That makes sense? So there's a different way this problem can be solved, much, much easier. You learned in the blue packet, and we learned in the last unit, that this integral, -4 to 1 of f, so we're starting here, stopping here. If that integral is synonymous with this area, but because this area is all below the x-axis, if you really could type this on your calculator, you would get a negative number to represent this. The area is not negative, but the integral will be negative because integration is just f times dt, and all the values of f here are negative values. So if you integrate, you're going to get a negative number, but it will correspond perfectly to the area you see here. So Matthew is saying no geometry today. There's a tiny bit of geometry. I don't know how it could be easier because this triangle is just half of that orange rectangle. The orange rectangle is 3 by 1. So the triangle's area is 3 over 2. Questions? Top's going to be 6. 3 multiplied by 2. So that's 6 plus 1.5. That's 7.5. So that's 15 halves. So the correct answer is -15 over 2.
Whoa. Time out. I thought I knew all that now.
So let me say it again. Oh yeah, please, Grant.
can the answer be negative? Like
The value of
area?
the value of the integral is definitely negative because you can help me here. We're taking values of f, which are these, right? So are these f values positive or negative?
Negative.
Good. And then we're multiplying by, this tiny value that is dt. So the integral is definitely negative.
But can the answer be negative since we're looking for area?
What we're doing is we're actually not looking, you're doing great. We're not really looking for area. We're looking to find this integral's value. This integral's value is definitely negative 7.5. We're just using the fact that integrals can be used to find areas. Therefore, you can use areas to find integrals. That's all we're doing. Because you can use an area, you can use an integral to find an area, you can turn it around and say, oh, if I can compute the area, then I can figure out the value of an integral.
Equal signs just mean that
They're the same thing. If we really were trying to find this area using an integral, this is what we would have done. We would have integrated from -4 to -1, but we would have said 0 subtract f. If we were really trying to find the area. Because you take y at the top, subtract y at the bottom. Well, this is the same as this. So we figured out that this integral's value is negative 7.5 multiplied by the -1. The area would become positive 7.5. But the integral's value is definitely negative 7.5. 2 points. Harrison, question? Good. Anybody else? Please.
I just wanted to ask a question when you get to the derivative part.
Oh yeah, no worries. Anybody else?
The -1 on the first limit from x to -1. I understand everything else, but maybe just tell me why can we do that if it's x?
So the way you read the formula is, you asked how g and f are related. This is saying the value of g for some x coordinate, like the graph of g is, I don't know what, it's
Actually,
some other.
never mind.
You good?
Yeah.
2 point. No, keep asking. Please. So
Since that's the graph of f, and the graph of g is the derivative of f, that means that the point that on the graph of g at -1, the y value is negative 7.5, right?
Huh? Yeah, like,
So even though we're finding an area on f, we're finding a point on g.
can't say that better. It's really good.
Like how we're finding a
Yeah.
slope for derivatives on f, but a point on f prime.
Yep. Yeah, you can't say that better. That's how g and f are related. It's just a little complex because this -4 is involved. So what Matthew said is correct. On the graph of g, if you go to x equal -1, the y coordinate is negative 7.5. Where did that y coordinate come from? It's just this formula. I just use the formula. Plug in whatever x I want. Just use the formula. Just that when I plug in an x, I'm going to have to find some area to compute that. That's all. There we go. Hey, if you need to add something to your flashcards, I've showed you this flashcard several times, how to integrate. We've done Riemann sums, we've done calculator. For the last 4 packets, we've been practicing using the fundamental theorem and antiderivatives. Today, new idea. You can also calculate an integral's value using geometry, like really simple geometry. Question?
Simple geometry. So weirder shapes.
No, it'll always be simple. Yeah, they won't ask you to do anything complex. Yeah, that's not going to get, it's not going to get work. Okay, next thing. Okay, now we have to find g prime of -1. So let's copy this.
to get at g prime, you would have to take the derivative of the f of t d of t, right?
So grab your green derivative rule sheet and find the one formula you have never used on that sheet.
The derivative of an integral, oh joy.
Such fun.
Oh gosh.
Okay? So the good news is, listen, hey, the formula looks kind of like a lot. But if you listen to how I describe the formula, memorization is really easy. I need to find the derivative of my G formula. So I need to do this. G prime of x is going to equal d over, okay, because G is a function of x, I have to go d over dx. So don't get mixed up and put dt. The G function is a function of x. As I said to Jackie, the x really, sorry, the t is really just substituting for x anyway, so I need to find this derivative. So what you want to do is look at the formula sheet as I describe what I'm doing. On the formula sheet it says the derivative of f, the integral of f, sorry, is going to equal that same f formula, but notice in place of this input variable, they have plugged in the upper limit. Look at your green sheet. It says the derivative of the integral of f is f itself, like nothing changes. But you plug in the upper limit in place of the input variable. So I do that. So we need to describe that part of the formula again. Then look at your sheet. You are now multiplying by the derivative of the upper limit. So d over dx of x. In the formula sheet, they call the upper limit h of x just to represent that it could be anything. Questions? Now here's where the memorization gets really easy. It's simply subtract the, I'm writing in the wrong place. Hold on a second.
I'm confused.
That was confusing. Raise your hand if you felt confused. Give yourself 5.
I'm confused all day, every day.
Sorry about that. So right here, okay, after the subtraction, it's really easy because it's exactly the same thing. Simply use the lower limit.
So is this just a big glorified final person's initial?
Kind of. The formula is derived using the fundamental theorem. Like the other formulas on the green sheet, I think for our class it's better to not worry about the derivation, since you're not tested on that. Better to simply memorize the formula and use it.
This is a derivative.
But the subtraction does come from the fundamental theorem. So then I go f of -4 multiplied by d over dx of -4. That's how I take the derivative of an integral. I gave it to you on the sheet way back in October because I wanted you to make sure you knew that at some point we would need the formula. It just didn't make a whole lot of sense until we studied integrals. So, question?
Shouldn't that x be, shouldn't the x's that you're using as the upper limit be -1? Oh no, just kidding, it's an x in the formula.
Yeah, you can't ever plug in the number, then take the derivative, you'll always get 0. So you must take the derivative first, now we're going to plug in the number. But this is 0, this is 1. So we just figured out that G prime and F are the same. That's how G and F turned out to be related. So now you can plug in the number. Questions? Please, read.
Why is it G prime of x? So G prime is -1.
So let me give a comparison. I think will answer your question. If the problem had said g of x is equal to x cubed plus x, and then they said find g prime of 1, what would you have done? prime, you would have found the derivative first. So you'd find the formula, g prime of x. And then you'd say, okay, therefore g prime when x is equal to 1, now you plug in the 1. So you always apply the rules first, then plug in the number. So here I'm doing the same. I have a formula for g. I'm going to take the derivative of that formula just like you did here before I ever plug in any x. Once I have the derivative, now I can plug in the x. Did that answer your question? Point. Now, cool. So, without saying it out loud, please, feel free to talk to each other, but raise your hand if you can tell me what g prime of -1 is. To everybody. Just look at the board, it tells you. So what's the numeric value for g prime of -1? Like, hands, show me your hands, come
I
on.
know what you're doing.
What do I want to write here?
I thought it was more ways, like which one is it?
If you don't see it, talk to somebody. Bell, finish your yawn before you call it. Getting ready to sneeze. So please raise your hand if you are in agreement with Bell. 2 points, 3 for Bell. Question? Yeah, you just look at the graph of f, go to x equal -1, the y coordinate's -2. So I say the homework isn't hard, you just follow the rules. It feels kind of awkward because it's a little different, but you just follow the rules. Question? Okay, we're supposed to find g double prime of -1.
That's not differentiable.
You're a couple of steps ahead, so let's just make sure everybody else can see it. The formula says g prime of x is equal to f of x. Therefore, g double prime of x is equal to f prime of x. Question. So now, just like Bree did before, we say g double prime. Make sure when you work this problem you are using the equal sign with all the right symbols, otherwise you will lose points on a written test. F prime of -1. So Harrison went here. He says, hey, I can't find, f prime means the slope of f right at that spot. But as Harrison noted, because that's a corner, I can't find the slope of f at that spot. That's why the problem allowed you to write does not exist. Question?
It doesn't exist because there's a corner.
Correct. Because f has a corner, I can't find the slope of f at x equal -1.
Without the correct notation regarding that.
2 points.